So we're going to take a look at the coordinate plane. It's also called the Cartesian plane, and it has 4 quadrants. So this little box here in the Word document shows the quadrant numbers. So this is called quadrant 1, 2, 3, and 4. And in the quadrant over on desmos.com, this is the first quadrant, second quadrant, third, and fourth. So the way this works is we have 2 axes. Okay, we have the x-axis running across, and we have the y-axis going up and down. It starts at 0, 0, and this here is an ordered pair. And so the first number in the ordered pair is for whether you go left or right on the x-axis. So the origin is over 0, I don't go anywhere, and up 0, so it's at 0, 0. Other ordered pairs, and we can plot some points here, we can say I'm going to go over to the right 3, and I'm going to go up 1. And there is over 3, up 1. Now, if I go negative, I just go to the left. And that's in the x. And the y, if I go positive, I go up. If I go negative, I go down. So let's plot a point in each quadrant. So now I'm going to go for something in quadrant 2. So now I have to go negative 2, and I'm going to go negative 2, and I'm going to go positive 2. So I'm going to go over to the left 2 and up 2. All right, now I'm going to go into quadrant 3, which is over to the left and down. So it's negative, negative. So I'm going to go negative 1, and I'm going to go negative 2. So over 1, down 2. And finally, quadrant 4, I get to go positive again on the x-axis. I'll go over 2, and I'm going to go down negative 1. So I was trying to pick points that had different values so that we could see that the order obviously matters, and the sign matters, positive or negative. Let's see. The other thing I just wanted to mention, well, I'll get into lines just in a little bit. So I wanted to mention, there's 2 kinds of lines I want to mention. The first one is a constant. Okay, so we can say like y equals 1. Okay, so y equals 1 says we don't care what x is. In every case, y will be at 1, will always be up 1. So it's not over 1 and up 1, it's just up 1. And the line is extending in infinite direction in both ways. Now I could add a domain to this, which is to say I only want it to go from negative 3, right, on the x, so it's x has to be greater than negative 3, and it has to be less than, let's say, 4. And so now it only exists, so this is a line segment now. It goes from negative 3 to positive 4, and x is going to fall in that range there. And if I delete this out, it's going to be back to a line, and it's going to go on forever. And these lines are always flat if I say y equals a constant value. The last line I want to take a look at is the line y equals x. Now this is kind of like a copycat line, right? So every time y is looking for its value, it's going to do whatever x does. So x goes over 1, and y is like, well, I'm going to go up 1. X goes over 2, I'm going to go up 2. X goes over 3, I'm going to go up 3. X might go, I'm going to go negative 1. And then y will go, I'm going negative 1. I'm going to go negative 2. I'm going to go down negative 2. So you could have a function like this. And this is a line that has a slope. And the slope is 1. If we said y equals 2x, right, now we're making a steeper line. So 2 times x is y. So if x goes over 1, okay, y is going to be 2 times 1. It's going to go up to 2. So y is twice as big as x is. And this is graphing points and lines on Desmos.